So I'm going to do number 17 here to go over the central limit theorem here. So we have the redesign of ejection seats. When women were finally allowed to become pilots of fighter jets, engineers need to redesign the ejection seats because they had been originally designed for men only. The ACES 2 ejection seat were designed for men weighing between 140 and 211 pounds. Weights of women are now normally distributed with a mean of 171 and standard deviation of 46, which is obviously going to be different than what the distribution for men is. Now, if one woman is randomly selected, find the probability that her weight is between 140 and 212. So I need to find, here's my picture, and I want to find the probability that I'm between 140 and 211, okay? So I want to know this area right here, okay? So I'm going to use Excel. You could use the table, you could use the TI, whatever works. And you can see here I've written it in this. So I'm going to not start here. I said I was going to use Excel. It doesn't really matter what you use. Let's see here. Formulas, more function, statistical. Now remember with this, I'm going to use the normal distribution here. I don't want the S because this would be if I would have to convert, and I'm not going to convert here. So I'm going to start with 140. My mean is 171. My standard deviation is 46. And I want true. Okay? And then what I'm going to do is I'm going to do the second one because remember I'm going to subtract these. Now this is what we've been doing the whole time, right? Because I'm doing 1. So 211, 171, 46, and true. So what I've done here, coming back to my picture, is I found this area and this area. And now by subtracting them, that'll give me the pink area. So I need to do A2 minus A1. So then here, 55.75, this is the area. So this is telling me that this fits about, there's about a 55% chance that this fits one woman, okay? And now, so this is 1, this is what we've been doing. So my probability is about 55, so 55% of women. That's actually pretty bad. Now, the second question is 25 different women were randomly selected to find the probability that the mean weight is between these values. So I'm not going to change these, but with the central limit theorem and how we know that we switch, and this is what I wanted to emphasize, one woman is what we've been doing. We didn't change anything. As soon as we're given a group, so we're looking at a mean weight, that's really what we're doing here. Is we're doing a mean weight. Then we're using the central limit theorem. So then the new standard deviation here is going to be the old standard deviation divided by the square root of the sample size. So in this case, 46 divided by 5. So what I'm going to do is I'm going to come back here, and now I'm going to do the same thing I did before. Okay, but watch this coolness. So I'm going to now put in 140. My mean stays the same, okay? With the central limit theorem, the mean doesn't adjust, but the standard deviation now, 46 divided by 5. And you'll notice here, I didn't even have to do that. I mean, you could do that if you wanted, but it'll do it for you, which is nice, okay? And then I'm going to do the same thing down here. I'm going to come down here. I'm going to do it again for the other one. So, normal distribution. So 211, 171, this was 46 divided by 5, and true. And then, same thing here, I'm going to do now C2 minus C1. So now I have a 99% chance that we would do. So of my 25 women, there is a 99% chance, pretty much almost 100% as you start rounding this, chance that the group mean will be between these two values. But here's what's the last question. When redesigning it, which one's more important? Well, actually part A, because 25 women don't sit in that seat. One woman does, okay? And one woman is only 55% likely to be between that. Now, when I start averaging women, Obviously, the mean of 171, yes, some women do weigh exactly 171, but a lot of women are going to be less than that, more than that. They're going to go each way. So then the chances of an individual woman being between that is actually only 55%. And since each individual woman has sit in it, that group mean, yeah, I take 25 and I average them. Pretty good they fall between that. But that doesn't actually tell me, is each woman safe in the seat? Because just because it averages that doesn't mean that's actually where it ends up. So that's one of those kind of caveats with this kind of data, is when I start looking at group means, a lot of times that group mean isn't too useful when I'm talking about things that individual people have to use, like ejection seats or airline seats. Now, if I'm talking about like the weight in a plane, well, then yeah, I'm grouping 25 people onto the plane, their weights will average out. That's when something like that isn't going to have the same effect. So those are the things we kind of have to consider when we're looking at the central limit theorem.